Hello and welcome back, or welcome if you're just joining me for the first time. We're looking at question number 24 on the grade 7 Gauss from 2005. So, question number 24. On a circular track, Alphonse is at point A, and Beryl is diametrically opposite at point B. Alphonse runs counterclockwise and Beryl runs clockwise. So the arrows have indicated where they're running. They run at constant but different speeds. After running for a while, they notice that when they pass each other, it is always at the same 3 places on the track. What is the ratio of their speeds? Okay. So I think the key is figuring out exactly where those 3 points might be. Now, we don't know the speeds at which they are running. And we don't even know who's running faster than who. But does it really matter? Because if Alphonse was running faster, couldn't we just flip this picture and imagine that it was Beryl that was running faster? Things to think about. Alright, so passing at 3 different places, where could those 3 places be? Oh, we need some more paper. So let's draw our circle here. Okay, we'll see if we can do this with 2 different colors. We'll go Beryl with blue, and she runs, and eventually they're going to meet each other in this half of the circle. So maybe she's running faster. So she comes more than the halfway point. And Alphonse, I don't have a color that starts with A. I don't know, we'll just make him the red. So eventually they cross for the first time somewhere over here. Okay. Now, this, we might be able to tell something about this, because this is half a circle, and so however far she's come to however far he's come, we have sort of the ratio, B to A, and that's exactly the thing we want. But I can't quite tell where they're going to meet. Okay? But I do know they meet at exactly 2 other places. So, could we draw another semicircle? Well, no, they're at the same point there, so we couldn't draw another semicircle and do the same sort of thing. So what's going to happen? Well, Beryl's going to keep going, I guess. And they're going to meet somewhere on the remainder of this circle. Right? But Beryl will again come, and in fact, she'll go twice the distance B around. But she'll again come, and she'll come around, and Alphonse won't have gone quite as far, but he'll keep going. And they'll meet again. Okay. And now, at this point, it's really just the same as when they met here. Right? Once again, they are at the same point. Alphonse is going counterclockwise, Beryl is going clockwise, but they're still meeting. So where are they going to meet the next time? Same distance apart, because they're moving at constant speeds. Okay, so maybe we can make a note of that. After they meet once, so up here at 1, Alphonse travels, I don't know, distance x to their next meeting. That's at point 2 here. And then they're going to meet at another time at some third point, 3. But why would he travel more or less than he did the first time? Right? They're still starting from the same point. They're still going around the same sized circle. The next time he goes distance x, Beryl will have gone the other amount of the circle again, because they're moving at constant speeds. I spelled Beryl's name wrong. So since they're moving at constant speeds, he will always travel distance x between, so he's at 1, and then he goes to 2, and then he travels distance x to go to 3. Then he can't go back to 2, because that would be going x in the other direction, so he's going to have to meet again at 1. And then he'll go to 2, and then to 3. So, 1, 2, and 3, their meeting places are evenly spaced around the circle. So they each have distance x between them. Right? He doesn't travel x the first time because he's not starting at their meeting point, but it's x from 3 to 1. So 3x is the circumference. Of the circle. So now we've got an extra piece of information, or rather we've got a piece of information about this puzzle in terms of another piece of information. X, we're going to say, is the distance Alphonse travels between two of the consecutive meeting points. So 3x, because they have to be spaced evenly about the circle, 3x is the total perimeter. So from 1 to 2 in a clockwise direction, that's what Beryl travels, is, well, Alphonse goes x, so the remaining 2x Beryl must go. And this lets us compare their speeds. Okay? We could say something like Beryl travels at b meters per second and Alphonse travels at a meters per second, but it really doesn't matter. Comparing the distance they can go in the same amount of time does the same thing. So Beryl can move at 2x, or move a distance 2x in the time that Alphonse takes him to go x. So this is going to be divide by x on both sides because they're ratios, 2 to 1. Okay? And if you wanted to, if you're uncomfortable saying, well, no, that's the distance they travel, we're talking about speeds, I encourage you to stop and say, all right, let Alphonse travel at speed A and Beryl travel at speed B, and let t be the time it takes for them to meet one another. And let, 2x is going to be b times t, and x is a times t, and show that you really do get the same ratios between b and a that you do the distances that they've traveled. Okay? It's because it takes the same amount of time and their speeds aren't fluctuating. They're constant speeds that this works out. But we've got our answer 2 to 1. 2 to 1 is one of the answers. It is, I thought it was the first one. No, it's D. Right? Or do we want, ratio their speeds. Okay. For a second there, I thought it might be ratio of Beryls to Alphonses, and 2 to 1 might not be right. Maybe we need 1 to 2, but they don't give us that option. 2 to 1 it is. All right. Not bad. Not bad at all. So, that's question 24. We've got one more question to go. Question 25. Thank you guys for joining me. If you like the contest, feel free to throw a like on any of the videos. But other than that, I'll see you for question 25 in the next video. Have yourselves a wonderful day in the meantime.